Hello, everybody. So today we're going to be trying our third part in this however many part series. Our goal is once again to try to get through 40 floors today. I don't know how far that actually is in this game, but I'm going to try to go as far as I can, technically. So last we dropped off, we went from level 21 to level 30. So my goal today is 33, 34, 35, 36, 37, 38, 39, 40. Okay, so I'll be getting like to here, and then these last two will be for something fun, I guess. Let's just see how far it goes, though, because actually it's going to get a lot harder nowadays, which means I need to focus more. Try to see if I can get the code to work properly. String reverse. I already know what to do with this, I think. Put all the things in here, and then reverse it by indexing it. OL. Ole. Ole. Yadat. Ui. Era. Wall. Ah. Haha. Okay, seriously. First zero terminated string, reverse the inbox and output. Yeah, that's what I thought. Let's see. Every time I grab, let's say every time we grab something, we want to copy it to an index of whatever this number is. And then also, then that means we have to bump that number. Right? We have to bump that physical number up, not the index. Right. And then that means it's going to be an increasing number. And then if it's 0, we don't want it to rebump again. What we want to do is we want to decrease the number now. So let's say I'm at 3. What happens then? Well, if we were at the third position, this number would have been bumped 4 times, so it would be a 3. Which means we can just easily call it from that position. Copy from. Oh, the index of 14. We output it, and then we minus bump it down the physical actual spot, and then we repeat. So in theory, this should allow us to easily go through here and then go backwards, right? Okay, first step works. Oh. It bumped into a 4, so I should have bumped down first and then do it. Oh, and then I guess I also need to do a condition for if 0. If 0, then we can start back from the beginning. That's what I missed. Because if we just did the way we did earlier, it would just do one box and then it would just start from the beginning again, which makes no sense, right? That means we got to account for the zeros. Oops. Actually, what I'm going to do is I'm going to copy if negative, I think. Let me undo that real quick. So if 0 doesn't work because we're actually calling 0 right now, but we call it negative. and drag it to back where this was, we can get rid of the 0. Because if any number is negative, oh, that's gonna suck. Because then that number will be a negative number, which means we got to do initial bump first. Right, because then it'll be a -1, and that means the next box will start with a -1, which doesn't work. We want to have it to be 0. Am I overcomplicating this? Actually, I'm just gonna run it. I want to see what happens because I know what's gonna happen theoretically, but it's always nice to see. Now alive. Yeah, see, because the -1, it doesn't like it. Doesn't like it at all. So what we could do is have the initial bump to 1. So instead of bumping way before we bump way after, but that's gonna add an extra line, which I don't want that either. Okay. So preferably this has to be 0. I think I just have to do 2 bumps at this point. The first initial bump, and then afterwards just repeat all the bumps until it gets to 0. That does not work because the 0 is gonna be like, hey bro, what you doing? The initial bump idea was nice. I think that works. That works. I'm just trying to find a way to get the box to be 0 first. Because if it's 0, I still want to grab that 0 position. But then I also wanted to add 1 extra so that it goes back to a 0. Right? I don't want to just hard code it, right? Because that'll be kind of boring. Copy from 14, right? Outbox. And then bump it down. I'm gonna have to do 2 jump statements. If negative, and then bump it up 1, and then you just jump back to the beginning. So this way it automatically puts a 1 at the end, but I feel like that's kind of cheating because it hard codes. Okay, it's gonna be negative and then just back to 0. You dog. Bite. Dog bite you. Bite dog you. So not bad for a first try, but I'm just trying to figure out like a way we can optimize that because we use like bump 3 different times. Yeah, see? That decreased our steps, but that 2 extra lines. Not that great. Inventory report. Let's go. Inventory check. Account verification. Surprise audit. These are a few of the favorite things. So let's get started. For each thing in the inbox, send to the outbox the total number of matching items on that floor. Oh. Let me try something first. I want to see if I can subtract. If I can subtract these things. Okay, so they give a number if they subtract. Okay. That's good to know, actually. So for each inbox. Oh, actually, first thing first, what I want to do is I want to have, wait, number of matching items on the floor. Okay, I think I know what I want to do. First thing first, you always want what you always want to do. I'm gonna copy from this position right here because I want to have it like 3 zeros. One for resetting, one for counter, and one for iterating through the numbers. So what I want to do is 18 and 19 will become my counters position. 18, let me add a note here, will be my count. Actually, can I just add that to like 18? Yeah. Count. And this would be my index. So what an index is that is telling you which position the items are in. So before every inbox, I want to copy from, copy to. But for now, let me just simple it up. Get a first box, compare it with the numbers. If it's 0, I want to increase my count. Oh wait, but that's gonna get rid of my hand, isn't it? Is it? Let me try something. Bump the index of this position. Would it get rid of stuff on my hand? I'll find out. Bump. Let's see. Subtract if 0, add to the count. And I'll jump back in the code. Then what I want to do is bump my index, which is actually the sub. Let me change the index to whatever index this is. And then I want to bump my index by 1. So what this is saying is that first sub to 0. If it's 0, it'll add this one. But if it doesn't, it'll just go to the next. It will just bump this index position. So it's going to go 1. Checks this. But first thing first, I need to add it back, don't I? Yeah, I do. I need to add back based on the index of this number before I bump it. So subtract first. If it's 0, add 1, then go back in. Then add that number back so that it resets. Bump. So it increases the index. Then it will jump back in the beginning. Subtract. Do all that stuff again. 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 And then once we reach 13, how do I do this? How do we get it to stop at the 0? Because if it gets to the 0, let's put that mark here. If it reaches 0, I want to jump to over here, because now all I need to do is just copy from the count, and then we output that, and then we just go back to the beginning. Right? So we just gotta figure out this if 0. So that means we have to get here. We gotta be like, oh, if this number is 0, then we gotta stop it. Right? That's the logic of this section of the code. Because here, let me just go through the steps. Actually, no, the if 0 would kind of just disappear, wouldn't it? No, no, that's not. And I'm just gonna run through it. I want to see what this code does. Put it down, nice. X. You can't add with the letter. What would that mean? What? You can subtract the letter, you can't add the letter? That's dumb. That's dumb. Then how the heck do you compare? I guess the one way you can do it is maybe put the box in here and then compare each of these items to it. But like, come on, that's dumb. That's so dumb. Okay, inbox, copy to, because they want to do it that way. This, right? Then copy from the index position of the index. In this case, is 0. Then, if 0, like I said, we would just take whatever the copy from count is, and then we output it. So that works part nicely. We can get rid of this if 0 statement right here. But if it's not 0, then what we want to do is we want to subtract that from this position. If it's 0 again, once again, we bump the count and we go back to jump. But if it's not 0, then we just go bump the index. And then we jump back. Wait, what is this thing? Oh yeah, we jumped. Okay, that we need that. We bump this Bach to initially where we copy from the index. Okay. This should work. Alright, we put that there, then we compare these items. We subtract it, they're not 0. Then we just go to the next part. These will be 0 in theory. Bump the position of the count. Oops, I meant to say bump the count itself. They should be the same, so bump counts. It'll keep indexing through the options. Nice. This is kind of a really bad method because you have to literally go through all the items to make it optimize. And you literally run through every single steps over and over and over again. The other option is what you could do is have all these numbers already accounted for. So like sort all the A together and be like A 4, B 2, C 7 or whatever how many. And then afterwards just easily look at each number and index it from there. So that'd be a faster method, I think, in my opinion, based on just the number of steps. But that's going to require a lot more coding than whatever the amount of lines we have here. It'll be a fun project to do in the future though. I think I can try to do that for fun. Let's just speed this up. We know it's gonna work. See, like, he has to go through all of those steps. It's kind of tedious. You have to index to 13 every single time. Or to 14, actually. Oh, cool. 16 lines. 393 steps. I took 4 whole 7. Oh, that's pain. It means I got all my code correct. I just misplaced the order of the code. I think that's what that means. Well, like I said, our goal today is just to go through all of them. And then next week, or next time, we'll just optimize some codes here and there. Where's Carl? Carol. Where's Carol? Rip Carol.
Oh my god. This coffee is amazing. Back to work, ladies.
Breaking. Previous reports of machine army evaluate to false. Everything equals 100% fine. Whether within pleasant tolerance parameters or human skin layer, you're all going to be fine.
You're all going to be fine. That's awesome. Okay, year 34. We're almost there. We're just old man. Yes. Management is attempting to reduce bandwidth by removing all the vowels from every word. Good luck. So they're a vowel, we just get rid of it. So this kind of copies from what we did last test, where we take the inbox. Instead, we have to index it though. So let's just copy from this and copy to this. So what this does is that it has another count of 0 in case I don't want to mess the 0 up. It's always nice to not mess things up. You grab the H. You will have to put it to number 9, for example. So now we have the inbox and we copy to. Now we have to copy from, and we're indexing this position. So what that means literally is that it will grab 0, subtract it from this box. If it's 0, then we just actually reset, right? Because remember, if it's 0 means that it's the letters, so therefore we don't need to worry about keeping them. We can just throw them away. But if they are not 0, then we have to bump index of this. And then we just go back and repeat from there. Copy from, but if we ever get to the point where the copy from, aka what the number index position is 0, aka number 5, we just have to outbox it. And by outboxing, I mean copy from index, copy from the 9, and outbox it, and then we just jump back to the beginning. So what is this jump? Okay, I need that jump. Yes, I do. This seems legit, right? So I'm just gonna copy that inbox there, grab the H, gonna put it to 9. It will just first disk this box, compare it, be like, haha, that's a bad number. Let me go. What? Oh, freaking index thing. Oops. Let's label this index. Index. Here we go. We can just call that 0. Z R O 0. So none of it matched, therefore it's valid. But this is gonna match, so therefore it's just gonna cancel. Perfect. Run through all the options. If it's a valid answer, it'll run through. TLRG. I forgot what they said the code was, but I guess we'll figure it out later. Kinda cool. I like this puzzle. I think when they added the index, it made this game a lot more fun because you can do a lot more optimization with it and just knowing how to like place specific items in a certain place. I optimized it perfectly. Let's go. Duplicate removal. Ha ha ha. You're fired. Haha, just kidding. But I do have a note here from our other supervisors. She's out sick today. She says, it's time to eliminate inefficiencies. Set everything in inbox to outbox unless you see the same value before. Discard any duplicates. Oh, this is the coolest challenge yet. Oh, I love this challenge. Okay, so what they want you to do, they're technically leading you up to it. Essentially, initially they showed you what if all the letters are there. Now they want you to incorporate what we had earlier, but now account for the new letters by adding it to the items every time. That's brilliant. That's so cool. So I want 13 to be my index again, because you always want to have an index when you're dealing with these intricacies of specifically knowing where to put your items. Squiggly lines, gotta love the index lines. So that's my index. What I also want to do is I want to copy it to 0. What I want to do is I want to copy to whatever my index says. So in other words, I'll have a box here all the time that tells me where my string or my box ends. Therefore, because like if you try to go call an empty box, it'll be like, haha, you idiot, that's wrong. Why are you doing that? That's stupid, kind of thing. So therefore, you need to find a way to get around that by having an endpoint. So now that we set up the endpoints, we can start from the starting point, where we have the input, and let's see, we have that input. We want to compare it. What I'm curious because what happens if there's like 12 letters? Because I want to put this box here and then compare it individual one, kind of thing. But that seems very inefficient. What if the What if I just added to one? So I copied the one. But how would it know that? I'm gonna put like a sticky note here to remind myself. End string. Or the end 0. Perfect 0, by the way. Here we go, end 0. So this end 0 is essentially the ending 0 that you need to have, otherwise the code would be like, ah, that's not an end of the string. What are you doing? Anyway, copy to 0. Or copy to the index of this number, actually. Bump 1, add a 0 at the index area anyways. Oh, but that bump is gonna, that's very iffy, because what if I have like a number here and then I keep bumping the numbers in the future? That's not gonna work. Unless I make literally everything 0. What if I just like skip this whole step by making everything 0? That could definitely be an option for me. Oof, apparently I'm dropping frame rates. Uh-oh. That's not good. Yeah, that's not good at all. Why am I dropping frames? Huh. Oh well. I guess I need to figure that part out later too. The key about these coding games though, you have to make it as logic as possible, because the more you think about it, you're just gonna get more complicated. So keep it simple and try to get as logical as possible. My logic is place a C down, have it know that the spot is empty. But how would I do that, right? That's the challenge. Because like the only other way you can do it is like bump forward and bump backwards, but that seems like a waste of like memory, right? Because you're just not doing what you should be doing. Unless we need 2 indexes. Index 2. So the second index will keep track of where the 0 is supposed to be, and then the first index is supposed to keep track of where the item is going to be. I can already feel this is going to be too complicated. Index 2, the purpose of index 2 will literally just be keep track of where the ending string should be. Which means I got to place the letter placeholder. LTR place hold place hold LTR placeholder. So copy from copy to this position actually, right? Okay, so index 2 will be my where the 0 is at, the ending of the string is going to be at, while my copy 2 will be where the number is every letter through the inbox. Let's get rid of all these things to organize it better, right? So what I want to do is I want to compare the index with the index. If the letters are, the numbers are the same, it means we reach the end of the string. Copy from index, subtract from index, jump if 0. If the number is the same, we want to do a certain action. If they are the same number, that means we reach the end of the string. And that means that all the letters does not match. So what we want to do is we want to bump first of all, we want to place this letter copy to whatever the index of this thing is, right? And then after we place that, then we got to bump up the index 2 to tell you, hey, this is the new biggest number. No, this is the new end of the string. And then we copy from the 0, and then we move it to whatever the index of index 2 is, right? And then, just to be cheeky, we want to have the outbox. But first thing first, we got to grab it from this spot. So this whole thing is telling you, okay, if it's a 0, it means that it reached to the end of the string. We first got to add it. Well, actually, we can easily just put that there and then call it day because we don't want to repeat lines. But we copy it to where the location is. We output that box. Then we bump where the 0 is supposed to be. Grab a 0. and then put it to that box, and then we just reset. And by reset, I mean this. But I don't want this to be here when I do the reset though, because that tells you the end of the string. So does that mean I have to do what I think I'm doing? No, because at the end I'm holding 14, right? Yeah, at the end I'm holding 14. So this should work. This should make it 0, no matter what happens. I just gotta be careful of the stuff I do in between afterwards then. Okay, what is this? Inbox, copy to, index, sub from. Okay, so this is just checking to see if I'm at the end of the string. But if I'm not at the end of the string, I have to then compare the items. Index in this situation should be 0. So what I want to do is I want to copy from whatever the index of this number is. I want to subtract it to this thing. And if there's 0, I'll put a note here because I don't want to get rid of like all the bottom stuff. Anyway, if there's 0, it means that they're the same letters, right? That means they are the same letter as the one that's already in the list. If that's the case, then we just restart. But I gotta make sure I copy from this number first before I restart that. So that's what happens if they are the same letters. But what happens if they're not the same letters? If they're not the same letters, then you just have to jump, essentially, right? Because if they're not the same letters, it means that you gotta keep going to the next one. Copy from index. All right, copy from index. We also gotta bump the index too, just in case. So this bump will make this number new. It'll grab the new item. And then it will subtract. No, I think I do need to go up here too, because I want to check to see if the numbers, when they bump it, if they match or not. So I think that requires that to go up there. And now I place my placeholder out. I'm just going to test it. First try. Let's go. Grab the 0, put it in box 1 and box 2. Nice. C will go to here. Check the numbers if they're the same. They're the same, so let's add it to the first box. And then we can just dump it out. Okay, you can't bump a letter. I think that's what I mean. Okay. So far, the first letter works nice, though. That's good to know. So they're not the same, therefore you can just throw it in and dump it out. Nice. I wonder why I placed that 0 there. I don't even check it, do I? I don't think I've touched that 0, besides just adding the box in there. They're the same. Checks. Compare. We're good. They're not the same, therefore we bump to 1. That whole 0 thing is useless, I think. But yeah, so far it looks like it works. I'm just gonna speed forward just to see what happens. So the whole code works. First try. Although I've definitely used a lot more code lines, yeah. I think I can first of all get rid of some steps by just moving from copy. What is this? Bump index 2. I can definitely get rid of like a few lines just by, like, for example, this useless. That's kind of useless. That's kind of useless. Because what I really want is just copy from 14 goes here. And then that should work the same amount. This time there will just not be the 0 at the end of the code. Because that wasn't really needed. It automatically figured it out with my other code. So it was a redundancy situation. Where if my initial index doesn't work, it would have worked, like it would have like cached it, but I don't need redundancy in this if we're trying to optimize. I just want to see if this works first though, because I don't want to like put it down like, hey, let's see if it works, and then mess up badly. I still used 3 more lines than I needed to. And I used a lot more steps than I needed to there. I wonder if the method you're supposed to do this doesn't use double index. That's what I'm curious about. Also, what the heck? I have this here, and then I have this jump back to the beginning. So this whole section right here is useless. Where does this go? To the beginning? Okay. Well, I guess I know what I'm fixing. Because that jump was useless. What does this jump do? Okay, that ball jumped on the index. I need that. Copy from letter, copy to index, outbox, and then pump index 2. Okay. All of this was needed to make sure my index increase. What about you? This is if the index are the same, which means that they've checked all letters and that they're good. And this looks like it actually works too, so I saved myself 1 line of code. Realistically, that doesn't really save many steps. I don't think it does. But I optimize it enough for now, so I can, like, in the future look back and be like, this is dumb, or this is like super smart. Only time will tell, honestly. There we go. Yay, 17 lines. I saved myself 3 lines of code. Please be advised, this is an optional hallway. Advanced employees only. Yes, indeed. Goodbye. Click. You will receive 2 words. One's a decoy, a false lead, a red herring. The other is a important message. Okay. The inbox contains exactly 2 words. Determine which words come first. If you were ordered them alphabetically and send that. What? The inbox contains exactly 2 words. Determine which words comes first. If you were to order them alphabetically and send only that word to the outbox. So what? What? I'm gonna need an example. Yeah. Under dirt, your outbox should be dirt. Okay. I guess it's just the first letter that measures like if it should or should not be going through the end. But my question is, how many letters are in each word? Because we have like all this space, but that's not really enough space, I don't think. Also, why is there a 10? Why would they just give us a 10 randomly like that? You know? Unless they are thinking exactly what I'm thinking and we give them 10 boxes per spot. So this way the index would just be a 10 and a 0. Okay, what I want to do is I want inbox. I want to do an index and a counter. So first of all, copy from. I always want to do index and counters. They're always fun. So what this does is that it gives me a duplicate in case I need to mess with any numbers. Chances are this is the first word. First. W, first word. Second word. Position, right? So what you want to do is you actually want to jump is 0. And then you have 22 as your actual index. Actually, no, that's dumb. But I'm just gonna add the letters in just in case. I want to get my ideas through first. Because then if I have an idea of my index, I don't even need to go through the other options. Jump to 0. Index. I want to bump in the theoretical position of the index. And then if this was the correct 0, I want to copy from 10 and put it at my index position. And then I just jump back and repeat the starting position or copy. Oh, that's okay. That's why I was like, why did I just what? Inbox. If it's 0, I want to go to the next index position. But if it's not, I want to copy to whatever the index here says, and then bump, and then after the bump, then you just repeat the inbox. If it's 0, if it's not 0, then it would just go through, put the box in, bump the index, yada yada yada. Then what happens if it's 0 on the second time? Because that is a good question. Ooh, I can do a comparison, I think. Jump if negative, actually, and go over here. I want to pick up my index position, and I want to subtract it. From that number. So what this is saying is that I will take the 10, I will subtract the index. If the index number is bigger than 10, which if it goes with the 10 number it already is, it will go down here. But if it's not, it's just going to go back and repeat based on that requirement. Okay, so this is what happens if the numbers are bigger. So this is a whole new section of code. Just gonna add a line here. Part 2. So part 1 was just putting all the letters down. Part 2 is where we figure out the letters, which is actually really easy. Is if you do the code logics, you just have to look at the first letters. Copy from 0, subtract this letter. If it's negative, that means that, let's see, 5 minus 10, which means that that goes first. If it's negative, then we just copy. Copy from 0, and then we want to copy it to the index, but if it's not negative, then we want to copy from the 10, and then we also want to just jump to the index. So now that we have all our letters, right? That means now we just have to outbox it. Copy from where the index is and then outbox it. But if it's 0, we stop. And then if we stop, we go all the way back to the beginning. Okay, so index, inbox, it was 0. The inbox is 0. Copy from 24. Okay, actually what I want to do first is to place it down. Whatever the index says. Because I want that 0 to be at the end, because that's how that 0 right there will interact with each other. I wish I had like a drawing map. I feel like this would be so much more easy to understand if you have a map to draw on. But for now, this is all we can do. You can't bump a letter. Ugh. I know, I got it. Index 1, bump that up, bump that up, bump that up, and then just grab that, put that there, compare it, it's a 10, then that index is now a 10. Alright, and then we compare it. Oh, let's compare it if they're the same. I hate this so much. Oh wait, are we supposed to compare each letter? We're supposed to compare each letter. Are you serious? Are you? Oh, wow. Okay. Okay. You know what? Where did this jump from? Okay. Part 2. I'm so glad I did that. Okay. Part 2, copy from sub 10. What? Copy from this position, sub, whatever is in this position. If one or the other, then we just output. Right, copy from this or copy from that, then we just output that letter. And now what we want to do is we want to bump up both this and this. So now they're the new index. And then we just repeat. Part 2. Union units. So in theory, we will compare the letters. Okay, so in other words, if it's at 0, let's do that. This definitely has a lot more room for optimization because I had like different ideas coming into this, but I just want to see if it works. So what this does is that it looks at the U's, and then it's like, yeah, you know, the U's, they're the same, and then we bump it up the numbers because we don't have to worry about the future numbers. We have to worry about future numbers. I would then index it to, you know, first word, second word boxes, but we don't have to worry about that. We're good. And then I'll compare it. What? Bad output. Management expected O, but you outputted I. What? Wait, what? The O is after the I. Excuse me? Wait a minute. I'm gonna take a screenshot of this. Ordered them alphabetically. Yeah. Alphabetically. The O should be... What? Right? That's an O, right? The union. O minus I. I, J, K, L, M, N, O. So it's the difference between 7 and 1, which is 6. Right? Management expected O, but you outputted I. Why? Why? Can someone tell me why O is before I? Unless they're saying that's a 0. Which we know it's not. Am I the crazy one? Management expected T, but you outboxed E. Okay, so it was my original theory that was correct. They're gonna make me restart, aren't they? They're gonna make me restart. Okay, you know what? Fine. I will please you. I will do what you want me to do. Inbox, jump is 0. Okay. If it's not 0, copy to index position, bump index makes sense. Jump, right? So that's gonna go do what? If the numbers is 0, which means that the letter ended. Copy from 24, subtract index. So in other words, if they're negative, it means that this is a small number. Wait. Copy from 24, subtract index. So if it's a negative number, it means that this number is already bigger, so we just go on to the next step. But if it's smaller, then we copy from 24 and then copy to index, and then we jump back to the beginning and index it again. Okay. That works. Part 2. Part 2 is when we compare the letters. Copy from 0. What? Why would I copy from 0? Okay, you know what? I actually am gonna do the copy from 23 index to 0, and then copy from 24 and index it to this. This is gonna waste me a lot of space, but I want to get an idea out of the way first. So what I'm doing is I'm first subtracting the first from the 10, which I should technically be indexing of this and this. So what this is saying, if I thought this through correctly, is that the first letter, if there's zeros, then we got to go on to the next letter. Bump this, bump that. Then we jump back and compare it again. But if they are negative, then do whatever this says, and if they're positive, do whatever that says. Copy to index. Copy from index. Outbox. But if it's 0, actually, I don't care if it's 0 because it'll just end the code. Okay. The first step was pretty... Oh. I was gonna say the first step was pretty standard, I think. Compare the first letter, and if it's good, we just put it out. So we gotta find a way to end the code, essentially, with what they're saying. Which is why I guess I should have copy to the index of whatever this was. And then I have if 0, just go to the end. So what this does now is that it's going to grab the zeros, keep it in the coded line. Then I'm just gonna add the numbers. Okay, it says that I have some errors. Only nice, respectable pairs of 2 letters or 2 numbers are allowed. Ugh. Then how? How am I supposed to compare the un versus unity? Am I supposed to just pick the un first before the unity? Because they're the same words. Right? Am I crazy? Does the length matter? I guess jump is 0. Like, that's the only option I can think of, realistically, right? "30 lines or fewer." Oh. Okay, so the 30 lines is actually not too bad. My only big concern is that freaking these two, if they're not the same lengths, how do I deal with that, right? Am I supposed to have another counter? That's what my mind is jumping to right now. If there's a counter. And then I just compare the counter. But where am I supposed to place the counter, right? Because there's literally no space left. Unless I'm supposed to put the counter at the index position too. Okay, so now this is my new counter, quote unquote counter. No, because I need the position beforehand. Oh, that's gonna be tough. Because what I want to do is I want to have a counter, and then I want to subtract the numbers based on like how far they are from the index, stuff like that. But that's just gonna give a chaotic mess. Let's see. I guess that works if I have like a counter and a second counter. And then I reverse it afterwards. But that's stupid, isn't it? No, because I have subtract. Actually, I have subtract. That might work. Okay. Counter 1, counter 2. Copy from 23. And copy to all these indexes. Okay, I have an idea now. Instead of first word, this will be counter. Right? And then what is this one going to be? This one is going to be my max word length. So max word length will essentially bump it up every time I add a letter in at the end. But how do I do that? I guess I can base it off of the index. So for example, let's say back here, if inbox is 0, I do certain things here. Copy to index position, right? Let's say it's 7, which means that there's 6 letters. I want to... What is copy from 24? 24 is 10. Sub-index. Jump if negative. Okay, anyway, that means I have to do something here. In this note area and this note area, based on the fact that I want to compare it to the other numbers. Let's see. Let me neutralize my mouse first. Okay, sub index. So currently index has a specific number. I want to copy from the index position and copy to this max number position. Because what this is telling me that it's the number is the index. And then if I were to go down here, copy from the index position again. I want to subtract it from 10 so I can get a good decent clarification between the two numbers. And then I want to subtract that number with the max. If it's negative, I want to just move on, but if it's not negative, I want it to replace that right there. Max length number. Right, okay, let me just check back if this code makes sense. Copy from sub 24, subtract the max number. So what happens if I subtract the max number? Let's say this was a 9 and this was a 2. Subtract, this would be a positive number, which... If it's negative, it means that the original number is already bigger. Okay, that actually works. Let me just test this out. right? Let me skip to the word real quick. So this gives me a 5-letter word. Nice. That gives me a 2-letter word. I missed it. Oh, okay. Sub 24. Oh, it doesn't let me run through the iterations. Okay, I have to go through it manually, huh? So that's 12. It'll subtract the 2. It'll be a negative number. Which means that the number is smaller. It means I have to do the opposite of what I want. Yeah, it's because it's the opposite of what I want. You know what? How do I do this without like messing anything up? This is definitely a tough challenge. Because like I'm really close. I just need to figure out the last part of like the letter sizes, which is the tough part. Unless I guess I know what has to be done. I want to copy from subtract 24. I want to copy it to this position right there. Screw optimization for now. Copy from this, not 16. I mean to say the max. And I want to subtract it from here. And if they're negative, then I want to copy from the hand, right? Wait a minute, copy from oh, this is a brain headache. right? Because that's going to be a 2. So the 3, right? So that means that it's a positive number. It's going to skip. What it should have done is copy from 2. Copy to 5. That worked. That worked. That worked. That worked. That worked. I wonder if the counter max can be reduced. You don't really need it to add it to it later, right? Yeah, you don't need it. Okay, so we were able to figure out the problem with the size of the letter. Now we have the size of the letter right here. Now everything is flawless. How many letters am I using? Oh, 42 lines. Oh, that's a pain. That's a pain. That's a pain. But it must be done. I want to get this working first before we can optimize it. In the future stream, of course. Let's see. How do I do this? Well, we already have all the functions from earlier. It does exactly what it needs to do. The only problem is I need to stop it at the comparison. So let me just look at the beginning, copy from index, nice. Copy from, crap. Okay. So now that we have everything, let's index it properly this time. Instead of counter, we're gonna have to use the 23s and the 10s. If they're a 0, bump up the numbers and bump up the counters. And then we jump back to the beginning. Right here. Copy from sub. So before we even do anything, we gotta make sure if the counter is bigger than the max index. That's what I want to figure out. Right? Copy from counter, it's 0, minus index, let's say it's 2, which means that the small counter, if it's smaller than this, it will continue, but if it's not count, so we actually should be doing the opposite. If the max number is greater than the counter, then we just keep going on. But if it's less than the counter, then we just got to pick the first letter, right? Or the second letter. Anyway, you gotta figure out one of these options. Copy from, yeah. I'm just gonna do this for now. I just want to test it out. Undo, uncle. So the first letter is matching, the second letter is matching. Okay, I gotta go back to where the outbox is. Copy to index. Ah, okay, so that's the problem here. The copy from is no longer is tainted. So what we want to do is every time we do that, we subtract it by the counter, and then we copy to index. So that way, thought I fixed that problem. Yeah. Oh, I guess I put if negative instead of if equal to 0. Because it's never going to be a negative case if we stopped at the 0 mark. Yes, I know. In case, yeah, in the beginning. Okay. Last case scenario. Last case scenario is if the number is small in the front. This jump if 0 thing I did right here is my shortcut. I just want to see if it works, and it did perfectly. But now I gotta have an option for if it's a small number or the big number. So what I'm gonna do is I'm gonna put a note here. Or I'm gonna put a note here. And I'm gonna jump to the end. Actually less than the end because I gotta jump back anyways. So this is for if situation comparization. Oh, I hate this so much. Because I need another box is what I'm thinking in my head. I need another position of index. But the question is, can I use the index at all? Let me check back here. Have I used index? Copy from index, subtract 24, copy to counter. Okay, so in this case, I didn't use index at all, so that means I can probably use index one more time. Copy from 0. Let's see. If negative. I mean, it's positive. Let's see. Which situation is this? I keep forgetting. There's gonna be a extreme amount of coding lines, which I hate, but I just want to get a process answered kind of thing. I'll run through this real quick. Okay. Wait, what? Didn't I just make a code here? Or did I mess up? Uh-oh. Copy from index, put to index. Jeez. Okay. So in this case, as you can see, based on my index number, I hate this so much. The index is telling me that the second letter is the one that has the smallest amount. So based on that, we can copy it from here. Blah, blah, blah. Max counter, sub counter. If 0, right? So if it's 0, then we gotta look at the index. Bump minus index. If negative. Okay, so bump 0 is negative. If it's negative, it means that the first letter is the smallest one. Therefore, I want to copy from index 23. But if it's the bigger one, then I want to copy from index 24. Please work. I think it's gonna work, but like, this is such a bad code because of how long it is. So the second letter is shorter. It's gonna be a negative number, which means it's gonna grab from. So was it the opposite? So as you can see here, unit has less letters than units. So it should be a 1. I mean a 0. But it fails another, but let's check. This is like the worst case test I've ever seen in my life. Right? It's -1. Which means you jump all the way to this one and you copy it from... See? I thought it was supposed to be 24, right? Yeah. So I was right in the beginning in my estimations. It should have... This is the correct way. Right. Same number, therefore it's going to look at the index, subtract 1, So we know that it's going to have to copy from 23. Subtract the counter. Copy to 0. Take that. Enters. Nice. Right. With 0, we're good. I don't understand. What's wrong with it? Okay. So, for some reason, this did not bump. I'm just gonna let it play at this point, reset it. It's gonna work on this one. I think my problem is this. I think it's this one bump 0 thing earlier. Is that back in debug? It did not do a bump 1 as I thought it would. Essentially, that's what it boils down to. Right, 2. It's obviously less than 4. Where's this in the code? Right, it's not negative. We'll just copy from that. Copy to this. Copy from 23. Copy to index. Bump index. Stupid. I put that at 0 when I shouldn't have. I wrote myself bad code because of the assumptions I've made. But geez, 50 lines of code. Jeez, that's not good. Yeah, 56 lines of code, that's awful. I definitely could optimize this in the future, but I'm just done with that. Never again. Never again. Cough, cough. Yes, it's getting a little drafty here. Facilities may have been notified, but still has work to do. Oh, is this a hash? Oh, this is a hash. So, okay, so a hash is essentially an index where, well, actually, maybe this is like a, I would say this is a node, to be more precise, if I had to say something. Where a node is like, you have an index position, and then you also have a data assorted with that index position. So the way that that works is that it's just easier on the computer because it doesn't, all the data doesn't have to be next to each other. It could be just anywhere in their computer system, as long as you have a way to link from one node to the next. That's what it looks like to me, just on this formatting. But let's see what it says. Each pair on the floor contains data, the address to another one of the pair. Yeah, so this is definitely a node and definitely linked list. If you're ever interested in learning what this is, look up linked list. It's a pretty cool concept. It doesn't save you space, but it saves, like, it doesn't require all the data to be next to each other. You just have to know how to reference it from one to another. A scramble chain. Each thing in the inbox is an address to one of the pairs. The outbox data for that pair. Also the data blah 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 blah. The chain ends once you reach a native address. Repeat until the inbox is empty. Okay, so look at this. 0, E. Grab the E. It's gonna go to 13. Go to 13. Grab the S. Go to 3. Grab the C. You know. So this is called a linked list. Very, very cool concept. I really love it. It's definitely one of the cooler ideas out there, that's for sure. Let's copy it to 7. Move to. Whatever 7 says, right? Output that. Bump up 7. Copy from the index of 7. And then copy to 7. Instead, I'm just going to do a jump loop. If negative, then you just want to move on. That should work. Definitely a lot easier than the last one. But yeah, isn't that cool? It references linked lists. You got 13, which would be like, hey, that's this spot right here. Let's put that in, grab the S, go to part 3, go to C. It's such a cool concept. I always liked linked lists. Not coding it, obviously. Coding it just awful. But the concept of how linked list works is so nice. Escape is out there saying. Escape. Ah. Escape ape. Yeah, this is the most optimal solution for this code. Still though. Linked lists. I didn't realize they teach you linked lists in this game. That's such an awesome concept to learn. But hey, we're back to suffering now. Let's see how bad this suffering is gonna be. Our user have been rating one of our hardware products with a 1 star. With user recreating draws too much power and overheats. Numbers are too complicated for a test subject. Occasionally remove alarming volumes of skins from human user. What? What? Did he just removing skins? Okay. So this is an example of subtraction by subtracting. That's a dumb way to say it. But essentially what they want you to do is have 3 index numbers is what I'm going to do. Well, yeah, I'm going to have an index number situation happening here where, first of all, copy from this, copy to, copy to 4, copy to 5. So these will be the numbers that I'm actually going to figure out based on how far these numbers will be subtracted from the original number. Let's place the inbox number to number 7. I like number 7. Tony 7, you know, very, very nice. So now what you want to do is how would we go about this? Well, one way I'm thinking of is if we just take the 7 and we subtract the main numbers. Let's say subtract from this. If it's negative, you got to the next step. Oh, but we can do index now. Oh, that's awesome. Okay, you know what? I'm gonna use the index option also. I'm gonna put it at 1. Oh, but we can't use index because we had to have a way to get the number 11 by itself in the beginning. Wait a minute. The 10, the 10, the 10, the 10. That's so brilliant. That's so cool. That's so cool. Dude, they're amazing. Dude, that's brilliant. They got the 10 in, and now we just index the 10. Wow, okay, that's actually really cool. That's actually really, I enjoy that right there. Okay. Anyway, if they're negative, bump down the index, and then we'll just loop it back to the beginning. But first thing first is we got to add that that number back. So whatever the index of that number was, then we got to copy it to 7. But if it's not negative, then we just keep jumping back, right? Copy to 7, bump. That sucks. Bump 9, copy from 10, copy 1, bump, okay. Okay, so what I'm trying to do right now is, this will have to become a 1 for me to subtract it later. When I get the inbox, what I'm going to do is I'm going to copy to 7. I'm going to subtract it based on whatever number has been given to me. Copy to 7 again, so I don't forget the number. Then I want to bump to... I want to bump based on whatever the index number will be. And let's make it a 4. Yeah, let's make it a 4. No, let's make it... We have to make it a 5, actually. There's a lot of bumping happening here. Bump 3. Or as in this case, bump the index of 3. Undo real quick. Ugh, bump +9. Copy from 10, put to 4, bump -4. What does that mean? That means that we're going to start off with position 9 and we're going to start off with position 0. So that means we're going to look at these two numbers. Let's see. Oh, I love this, but it's hard to visualize it in your head without like drawing it out. This game is like 10 times better if you draw it out. That's for sure. But let's see, inbox, copy 27, right? Subtract from 1. Whatever index of 1 is. In this case, it's 9, right? Wait, what? Copy from 9. Copy 0, 1, 2, 3. Copy 0, put to 4, bump 4. Okay, so these will be my 0 counters, right? So the subtract should actually be from whatever the index of this is. So in that case, that's the 9. If the number is ever negative, you add that number back. You copy the 7. And then you bump that by positive, actually. So let's get rid of that and let's replace that with a positive bump. Then we jump back to the beginning of the code where we copy to what? It should have been copy from 7, subtract the 4, but if it's positive, copy to 7, bump the index of 3 by 1. And then you go back and you do it all over again. But there needs to be an end case, right? So the end case is if let's say it reaches frick. I'm just gonna change that to 5. Gonna change that to 5. Change that to 4. Change that to 5. Bump that to 5. Bump that to 5. So I need to use the 3 for something. How can I use the 3? Plus 9. Alright. Copy to 3. Bump twice more. This is a lot of beginning setup, but I think it might be worth it at the end. Now what I want to do is I want to compare the 4 or the 5. The Let me just put a note for part 2 actually. So that's the first part. Inbox, copy to 7. Subtract 5. Okay, so the 4 is what I'm looking for. What I'm looking for. Ha ha ha, that's funny. Let's see. In theory, if the 4 ever gets to 3, I want to do something else. Otherwise, I'll just add the 3 back. But anyway, if this is equal to each other, then we just grab it from box 2. We output it. Copy from box 1. Then we output it. Then we copy from box 0, and then we output it. This is dumb solution. I just wanted to have I'm not even gonna deal with the dumb solution. Bump negative 3. Copy from the index of 3. We output it, and then we jump back and redo it. If it's ever negative, we just jump out of it, and then we're good. Yeah, that's what I thought. Okay. Let's speed this up a bit. Okay, it's right. Let's go back to the beginning. Okay, 4, 5. That's a 1. 4, 4. That's a 2, right? That's a... Why? I need a copy from 4. So that's not where I do it. I just gotta do the initial setup. Gotta figure out if my original code works first. I just realized my biggest mistake. Okay, that's dumb of me. I'm just gonna reset the whole thing. The reason why I want to reset the whole thing is because of the fact that if I keep subtracting the 1s, it goes on forever. So I should actually be subtracting from the hundreds first. So copy from that, copy to 0, copy to 1, copy to 2. Let's copy it to 3 also. Actually, we'll save that. Uh, bump that number, copy to 3, and we bump it again. So this way I want to guarantee the index of 3. That's what I want there. However, now we need to copy it from the index of this number, and then we add 1. I don't think that's going to save me much space if I don't bump it. Yeah, okay. So in theory, this should give me a 3 there. That should give me an 11 there. And we're good. So we're going to start with this index. We're going to start with this 11 index. Perfect. Part 2. The inputs. Okay. So for the input, let's do something interesting. I say interesting, but it's not really that interesting. Let's put it in 7. Copy to 8. In case I want to ever use these 6 or 7 blocks, but I doubt it. But just in case, right? Copy to blah blah blah. Okay. Copy from, in case I ever need to do anything else with that. Subtract from the index of 5. If it's negative. If it's not negative, then we just copy to 8. Bump up the index of that. That way, actually it should be bumped down. The index of that, so that goes from 2 to 1. But right? Oh wait, no, this says bump negative with that, which means that's gonna subtract this. No, then it should be plus. Bump this by the index. That's just gonna be increasing numbers, but if it's negative, then you just want to add that number back. You want to copy to 8. Then what you want to do is you want to shift the index of this number down by 1. And you also want to shift that number down by 1. And then you repeat. And then you repeat. Now, how do we get out of the loop? Well, we need to compare 4 with 0. So if 4 ever gets negative, if it's 4 is negative, then we just copy from, let's say this index. We output it, and then we bump it. And if it's ever negative, if it's ever negative, yeah, if it's ever negative, we're done. Which means now I don't even need the 3 at all for the bump 3. Let's check how this works in theory. Okay, it grabs the 1, grabs the 2, grabs that, turns to 11, nice. Now I grab the initial box, place it in 8, subtract it. That becomes a 1, nice. Grabs it. That becomes a 2. Grabs that, that becomes a 3, 4. So now we index the middles instead. That seems pretty decent. Huh. So it worked for the first 2 numbers, but for some reason the ones didn't work. Oh, is it because I put jump to 0? It should have been jump negative. Is that why? Let's check this out. Okay, the 4 goes in. It's gonna be a negative number. Goes to 1. Negative number. Goes to 0. Goes back up to the top. Copy from 8. It's not negative. Bump 1. See, that looks like it works. Oh, but I guess because if it's 0, you don't. Oh, that's. Oh, that's. Oh, that's. Oh, 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 that's a pain. Because what if it's like 603, you know? So I guess I did need that initial bump in the first place. Bump 3. it's negative, you end. If it's 0, you start over. Alright, it's 60, right? 2 is not negative. Oh, I should have put if 0 here is what I meant to do. Yeah, because like what if it's 70, you know? Let's get rid of all this then. Let's see. Copy from here. If it's 0, go to the end. I just need a jump if 0 situation. But have it so that it doesn't jump if 0 if it's a, you know, decent number. Huh. This is the hardest part in my thing in the challenge, just figuring out the jump if conditions in 30 lines or fewer. Oh, I ain't gonna make that line. Let's think about this logically. What do we want? We want to get the first number. If it's 0, we want it to ignore the first number and go to the second number. But what happened if the first number is good, but the second number is also 0? That's what I'm concerned about. Or what if the answer is like 9, for example? Then the first two numbers are trash, but the third number is good. You know what I mean? Do I just need another index? Let's have 6 be my index. Front 0. So my front 0 person is what I'm gonna be counting from. So my idea is bump -1 for 3. Index, of course. Copy from whatever 3 says to copy from. If it's 0, you just restart. Actually, if it's 0, let's do something first. And if not, yeah, if it's 0, we gotta check. We have to do some kind of check. Output. And then jump again. Jump if negative. all the way to the end. Okay, so that part's set. Now he's got to figure out the zero section. If it's 0. What do I want to do if it's 0? I want to compare it to see if it's a legal number. If it is a legal number, we can put it in. If it's not, we don't. How do I make it true though? Oh, I guess in this case, up here, when I have the inbox, sub 5. What is sub 5? Sub 5, how do I want it? Subtract by the index of 5. If it's not negative, it means it's positive. Bump up 4. At the same time, how do I? Because I want to get the biggest number. It was going so well too. I had a good code and everything. Now he's got to figure out this freaking 0 situation. Let's see. Check if 2 is a 0. If 2 is a 0, then we want to jump up to the next number. But if it's not a 0, then we just this is gonna be such a sad pain. Okay. Do we want to do if statements? That's the question. If we want to do if statements, we can easily get rid of maybe some of the process. I could just easily do a first if it's 0. Yeah, you know what? Screw line optimization. We'll do this the manual way. Let's suffer for now. Okay. Copy from 2. If 0, go on to the next step. Copy from 1. If 0, go to next one. Right? So if it's not 0 though, you can just output that. And then copy from 1. Output. Copy from 0. Output. That's easy for 1. If there's nothing from 1, then we use this. Output. Copy from 0. Output. And we gotta make sure we have jumps in the end so we don't break our code. If 0, if not, just output. Easy. This is the manual code way to do it. Saves me less brain power, but it does make a lot of lines and a lot of loops. Right, because I forgot to jump at the end. Gotta go all the way back to the beginning. It's been so long that I've already forgotten how to do most of these things. That's funny. Yeah, as you can see, manually entering through all the options like a good robot. Tile with address of one. Oh, right. I gotta reset it, don't I? So instead of going from inbox, actually you gotta reset it all the way to here. Okay. Let's get this code running. Look at the guy go, he just like zooming by. He's just a speedy demon. Management expected at 3, but you output at 9. Huh? What happened here? Let's go back a few steps. You know what? I'm just gonna reset it. Okay, so the answer is 187. And then next is 42. Exam is gonna take a while. Okay. Everything looked like it reset. Oh, it's because I didn't reset the top. So I really have to jump all the way back to the beginning. But I guess that 0 is no longer there from the 9. So now I gotta reset everything and do all the steps all over again. I definitely saw like 3 optimizations I could have done there. The first thing is getting rid of that 9 duplicates that we've been having problems with. Because the box 9, position 9, it's like a size 1. The number was 1, but there are some other numbers we could do zeros for, some numbers we could do bumper for. You know, just regular index stuff. But hey, we did it. Definitely not the most optimal solution or the number of steps. A lot of optimizations can be done there. But that is for next time. I just want to get the solutions first. You know what? I'm gonna stop at 39 for today, and then I'll do 40 and 41 next time. Because I think that's gonna be 2 tough challenges anyways, so it'll be a fun watch for sure. Okay, pawn to b6. And check, and mate. Yes, I win again. I find the game most enjoyable when playing best player? No, myself. Uh-oh. We have to do indexes from these things. Each number in the box is addressed to a tile and floor. Send the address box coordinate at the top. First column, row second. For example, an address of 6 has a coordinate of 2 and 1. You may ask your boss for more example. Okay, this is gonna be annoying because like the 15 is literally right there and it's gonna get rid of this block. Which means I gotta find a way to move these blocks out of the way and not affect anything. Right? Unless we can put it at 0, which I doubt we can. Oh, this actually is very tough. How would we do this? I gotta sit down and think about this. So I know we want a 0, 1, 2, and 3 available somewhere on the map. Can we index it somehow? It has to be able to work with all numbers, all positions. That's the tough part. So my first initial estimate is to divide everything by 4, right? Because you divide everything by 4, you can easily tell the number is either in the first quadrant, second quadrant, third quadrant, or the 4th row. 1, 2, 3, 4. And then what you do is just subtract it from 4, try to see when it's equal to 0, and that'll be your new index. So let me just do something first. My goal is to copy from 14, copy to index of 12, and index of 13. So what this is my x. That's an awful x. My x and my y coordinate. Right? Let's say I input the box. And let's put it at 0 for now. Copy to 0. Perfect. Okay. So that's just a placeholder for now. The way they have these indexed here is just to trick you, I think. It's just there to help you understand, but not really required. So what I want to do Let's see, 1 plus 0, 2, 3. 6 is able to subtract 4 one time, and 6 is able to then be subtracted 2 times. Okay, that works. Sub from 4. If it's 0, or if it's negative, we both do the same thing. But if it's not at 4, if it's not negative, then we want to copy to that position. We want to bump up this one right here by 1. Nice. Sub 15, right? Let's see. If blah blah blah. If 0, copy to 0, bump y, and then we copy from 0. And then we do a jump right here. So this will just keep iterating the y's until it gets less than, 4. If it's 0, what I want to do is... Let's put that inside, actually. If it's 0, then we just want to put that box back to 0. But if it's negative, we got to do add back that number of 4. Otherwise, it'll be a named number, right? Okay, so based on this, now we have our first step done. We'll mark there. This is to tell you all the y's will be complete. It will tell you the y number. Now we got to find the x number. How do we do that? We subtract it by 1. Now that we copy to yada yada yada, we can bump up this to 1. So now that's a 1. Actually, no, wait. No, we don't need to do that. Because then the number will be exactly... It will be exactly 0, 1, or 2, or 3. And then we just output that. So we just output that. Copy from box Y. And output that again. So that should be the solution, right? And then afterwards, we just have to loop it back to the beginning. Management expected 2, but you output 1. Aw. Okay, let me just look through the code. I think the reason why is because it didn't register the second 0. Yeah, it didn't register the next 0. I see. What's the line challenge on this? 14 lines or lower? Oops, already passed it. I need to figure out an optimal way to do that, because I think once we figure that out, it'll be easy. But yeah, it looks like we got our answer. What? Okay. Grab the 4, get it down. Nice. Zero, which then should bump a 1. Because the 4 makes the initial one not 0. Okay. Yeah, that makes sense. Because then if I output that, I copy from 4. Wait a minute. Zero, comma, 2. The remainder should be 0, right? I gotta think about this. The first number should have been the singles and the second one should be that. Okay. Copy from 14, yada yada yada, nice. Copy from 0, subtract 15. If it's 0, which means that the first number should be 0, we just output that. And then copy from Y and you output that. Okay, so that means I need to find a way to make the Y a 1. Okay, this is actually really tough. Because the only time it's exactly zeros are these 4. Right? And let's say it's a 4. So if it's a 4, it will grab this, subtract, it'll be a 0. Which is a good first number. I also account for that. You know what? Let's just do something else. Copy to. Let's do that. Copy to X. And then copy from X. And then output. If it's 0, we want to put the 0 to X. And then we also want to bump up the Y value to 1. So then here. Copy X and Y. So the X and Y was very useful. It just takes a lot of code. Line. Very, very inefficient. Yep. But I will have to call it a day for today. We were only able to get to 39. I want to save these 3 for the next stream because those will be the harder ones for sure. It's definitely gonna take me more than like an hour or 2 for those. So yeah, that'll be very interesting to see how it's gonna pan out. But for now, I will have to leave it here. For now. I wish you guys had a great time, and I will see you all later. Goodbye.